Is it clear? Is it
It is clear, yes.
okay? Great, great. So I'll keep this tone and setup. Yeah.
All right. So nice to meet you. I'll be the interviewer, and
Sure.
we are three. We might be more.
Yeah.
If
Yeah.
you're okay, let's
Yeah.
prepare
Yeah. Yeah. Yeah.
the
I'm okay.
call.
Yeah.
And this will mean sharing your screen.
Yes. Yes. I'll do that.
Yes.
Once. Yeah. Is my screen visible now?
Yes.
Okay. Great.
And for the participant here in the call, I'm going to repeat it after when more people join, but it's basically reviewing a design, okay, and not necessarily doing a mock interview, but it's still an interesting exercise.
Okay,
Yeah.
thank
Yeah.
you.
Some might argue it's sometimes more interesting than a real mock because it's prepared.
Yeah. Yeah. So, from my side, what I could do is maybe in a couple of future sessions, I can, I will definitely come up with more topics and more interesting topic. For some people, this might look like very trivial design, especially in a setup where, this does not have any algorithmic choices. There is a fixed solution. So I specifically chose this problem where I don't have to, put a lot of effort on algorithm, but I can debate on the design side, the fault tolerance, the trade-off, and things like that, so that kind of I can prioritize on one thing rather than the other. So yeah, so that's the thing. One second. Yeah.
All right. You know what? Let's start in 5 minutes. I would like to bring more people.
Yeah. Yeah.
I'm
Fine
going to
with me as
ping
well.
everyone that we are completely ready, and I'm also going to pass the subject, which is I already did Typeahead search.
Yeah. Yeah.
Is your this web page, is it public?
No, this is private, my Notion.
Okay. Yeah, you don't need to make it public.
Okay, okay.
Oh, nice. We are 6. That's good.
Great. Great. Yeah.
I think it's good that we waited a little bit, and we might want to wait just two more minutes and start. For the people coming here, it's a special. It's not a normal mock interview. Shiwak prepared this interview, and he's going to submit what he thinks should be a good approach to use during an interview.
Yeah. Is this size visible to everyone? Do I need to zoom or something?
I like it.
Okay, great.
Anyone has difficulties seeing? If nobody talks, it means it should be okay.
Okay, we can assume. And my audio level is good, right?
Yes.
Okay, great.
And we are going to read the chat, right? I'm going to read the chat to think about questions to ask Shiwak. So feel free to write something on the chat if you have a question.
Yes.
During the mock.
Yes. For the interviewee, it might be a little tricky because when I open this, I get distracted completely, and then someone is verbally asking, and then
I didn't mean
lose
you.
track.
No, I didn't mean you. You shouldn't look at that.
Yeah,
I'm going to use that to use ideas to challenge your design.
Yes, surely. Yeah.
So feel free, other participants, to write challenging questions on the chat.
Sure.
All right, it's 35. Let's start. And instead of me, telling you, asking you questions, you can go through your design, and I'm going to ask clarifying question about first, well, what you're going to build. Like, it's a type ahead search, okay? But can you give me more details about what this is, the constraints?
Sure. So, first of all, thanks everyone for joining, and thanks for all the organizers for making this event happen. So, I'm Shiva here. So, today I'll be presenting type ahead search. So, this is a pretty common and known problem. So, this is something that is used in Google, Facebook, and Twitter, and things of the like, where we type some letters like I type TRU, and it should be able to complete to something like true or wish or something like that, or toy. So this is the purpose of this is to ease the end user's life. Basically, many times there are frequently occurring words or hot news items that we want to search. So this will help make it more user interactive, and basically user experience will be improved. So let me jump to the problem. So I've added some of the
wait a second.
Yeah.
What is true 35? What is 35 here?
What is 35 here?
Yes.
Okay, so okay, sure. So here, this is an image I have taken just for representation purpose. So here, this is basically the frequency of occurrence of the search that it occurred historically, and this basically adds up to the weightage of that item. For example, right now, I mean, maybe a month back or 2 months back, the weightage of metaverse was nothing. Now it has gone up like anything. So the frequency will be like 200 million or 100 million here. Okay. So whenever I'm typing meta, it that will help me pull out that result on top more easily. So
okay, so this means that you base the frequency on the number of searches made by user, because there is another way to build a type ahead, which is to build it based on the number of search that will be returned. So if you type true, there will be like 35 millions. But okay, now we know that your design is specifically for you rank based on the popularity of a search. from users. Okay.
Yes, yes. So
I just wanted to clarify that.
Sure. So I'll also just take maybe notes for my thing. 1 second.
This is recorded.
Yeah.
But I understand that you want to take.
I'll just take note. So what is another alternative that you have suggested? One thing I'm thinking is that we can have it like more like a frequency based, wherever the requests are coming, and we can maybe we can discuss later as well. Not a problem. So I'll ask offline. So I'll jump to the problem statement at hand. So this is like a sneak peek, just to motivate the end like watcher here. So this is kind of, for some people it might say that okay, we are jumping here, but that is not the intent here. So now I'll come up with the clarifying question. So the couple of things I have captured here is like as part of the type ahead search, do we need to support multiple languages? Typically we can say that, okay, like for starters, English should be just fine. So next thing is on what criteria do we sort the result? So I have assumed that frequency of result selection could
what
be
is result selection? What is result selection? What does that mean?
Yeah. So for instance, when I'm saying TR, and then the system actually shows me true, try, but I go on, and finally I select true there. So what happens is it means for me any of the prefixes starting with TR will actually end up it will show like 5 options, and I choose one of those. So that means for that specific prefix I meant true. Suppose that is the TR is the prefix.
Got it.
So yeah, so that is the intent, the frequency of selection of prefix to target selected result. So yeah, so that's the goal here that I'm trying to implement here. So another thing is
just to clarify, sorry for jumping in, just to clarify. So if you say that the frequency of result selection would be the criterion, then would it not, that would prevent adding new entries into your collection, right? So how do you solve that? So what if I don't select, but I type in a new query, which is not part of the existing results in your database or whatever store you have? You should also allow that result to be included in your collection. So I would think that the criterion should be the number of times it was searched. Don't you think?
Okay.
Yeah, because
so
let's say like
yeah,
let's say you type like TR, the user is only going to see 10 results, right? But maybe there is 1,000 results possible for TR. You only allow him to select like 10 results, or you allow him to select 1,000. We cannot give him 1,000 results, right? He can't. No website will allow this, right?
Correct. Yeah.
So based on search, I think I agree. Based on search is better, but here it's not really a mistake per se, because usually it would have been clarified by the interviewer.
Okay, sure.
Right.
Yeah, sure. So I can maybe consider that as well as part of clarification. So yeah, so that way we will capture new items here, and the next step would be that how do we so do we need to actually apply any sort of bad word filtering? So we are thinking, yes, as part of the scope we will have some basic filtering mechanism in place. Next thing is like what will the scale that we are targeting? So here as part of the scope I'm choosing like 1 million daily active user as a scope here. So so any other thing would you like me to highlight so that I can put here and try to cover up before closing the discussion?
So what we're gonna do is we're gonna scale it to Google size, okay? At a B. I understand that you want to start with A, but let's scale it after, okay?
Yeah. So we'll see like
Google.
Yeah, so
it's
maybe
more. I think it's going to be more. It might be 1 billion. I'm not sure, but yeah, it might be 1 billion search, not necessarily user, but search. 1 billion search per day. That's what I'm thinking of.
And for clarifying questions, at least one thing that I can think of the top of my head is we can ask the interviewer if personalization is required. But then that could be second priority because that is a totally different problem altogether. I think we can just mention that that is one of the things that can be done, but we don't know how to do it yet.
Okay, sure. Could be additional scope, but not yet covered, so to say. Okay, sure.
Yeah,
I think
Shiva,
that,
one more question on the scaling side, right? This is Krishna.
So
there are two parts of the this system, right? So there is one data ingestion and then another one is data retrieval, right?
Yeah.
Are you going to ask the interviewer about the scope of the requirements? Are we going to only focus on data retrieval versus the data ingestion?
This is a good question actually. At this scope, what I will do is I will just kind of assume that the search would be almost equivalent to the ingestion part of it for simplicity, and if required, one of those parts we can highlight. So at least as part of the design, I will be doing trade-off for the two flows definitely. Maybe on the scale, I will see if the read and write flow are very different. Then I will state that actually, although we are calling that 1 million daily active user is there, the read flow has 10x more scale than the write flow. So that I will try to estimate below in the estimation section. Yeah.
All right. I think a lot of questions are going to be answered in the functional requirements that you've detailed. So let's look at that.
Sure. So sure. So so I have some constraints that I'm assuming here, that only English support, no spell check, filter word supports are needed here. So now we jump to the actual functional requirement. So here what I will do is I'll more precisely document the requirement that what are the things that are needed. So couple of things that I have captured here are: users should be able to get up to 10 autocomplete suggestion for a given prefix of characters. User should be able to select the relevant choice from the suggestion. User should be able to capture, basically the system should be able to capture this choice. System should be able to build or improve the suggestion based on the user choice. So I think one thing that is not covered is what about new searches? So so new searches, because I did not start with that. So the new search or the search result has not been covered here.
So if you agree, the three, as we've said before, the three, we can remove it because like the completion is not going to be based on how often someone selects an auto completion, but how often a search is being made, right? So I don't think you need to do three, but yes, your system needs to ingest search. It needs to ingest search and index them, right?
Sure.
So I would replace this. 3 and 5 are becoming the same.
Yeah. Let me kind of reword this. That the system, so system should be able to ingest this choice or
not the choice, to ingest just the search. Unless someone see a benefit. I mean, I can see how you could benefit from ingesting the choice, but I think it's going to be too. We're not going to have time to talk.
Sure. We are saying, like, the search, whenever the search is clicked, that it shall become the injection instead of making an intelligent choice about it.
Yeah, sure. So the system should be able to is ingest or captured the result basically. So so that sounds good, right? So the next thing is, do we need any sort of pagination? So I think those things are not very applicable. So I'll just jump to the non-functional requirement. So in functional requirement, is the scope fine? Any other things would you like me to highlight, or any specific things you are looking at? You have to definitely cover this part as part of this design.
I'm just going to state the obvious. You're not going to care about the search itself, right? Your system is just a type ahead that completes
correct.
words. This is why you don't care about pagination, right?
Yes, maybe.
Okay.
Yeah, maybe. Yeah.
Okay.
So here I can say that actual search algorithms. Algorithms are not in scope. So fine.
And there is no context to the search, right? The subsequent words, Shubha here.
No context for simplicity. Yes, agree. Yeah. So this is what is there. So now going to the non-functional requirements. So the very first thing or the high weightage thing I see here is the system should have a very low latency, like maybe 100 millisecond I have specified. So is that fine? Do you want me to kind of target even lower number? Then I can put it and see how we can justify that. So
that's decent. It's I mean, it's one of the systems that requires the lowest latency in any product, right? But 100 is fine. We're going to try and find a solution together to make it the lowest latency possible.
Okay,
right? Because there is a trade-off.
Yeah. Sure. So typically like 10 millisecond would be awesome, but let's see how far we go there. So next thing is like the scale. Initially we will design for 1 million and we have to scale to 1 billion daily active user. So next thing is the availability. So I've just put like maybe
for the scale, it would be good to clarify instead of the number of users, it would be good to talk in terms of how many queries per second you would get. That would be a better indicator of how many
I think
searches you will be able to handle.
He's going to do back of the envelope right before.
Yes. So I'll try to cover that as part of envelope. If not already done, definitely I'll try to cover that. So the next thing is like the high availability. So this is I'm just capturing as 99.9. So this is again a critical question, or people like ask like I want high availability. So we'll see like if we are able to justify with certain solution. So this is from the client perspective, what I'm seeing is the read-write ratio, it will be something like typically in the order of 1:1 or max maybe 10:1. So I'm typing a lot of characters, like up to 10 characters, then probably from the client perspective, it will be like 10:1. That is what I'm seeing. Like I will just say TRU. So every time I will get read, and finally then I will select that true. So I'll just, instead of 1:1, I will try to make it 10:1 here. Makes sense, right? So the next thing is I'll target here as part of this non-functional requirement, like I will choose availability over consistency. The thing is that this is not a financial system, and once in a while if we miss one of the numbers or the aggregates in the frequency, it should be totally fine, but things should be available to the end user even if there is 1% deviation from the ideal number. And the last thing is
there's a question I'd like to ask for that. So give me a scenario where it's not consistent and you're okay with that. Okay, a clear scenario where, let's say, Bob makes a search in your system and how it doesn't affect your search. It only affects your search eventually. So to tell me a scenario that illustrates consistency and not consistency.
Okay, so the very first thing I'm seeing here is that though there are some hot words that are already in making, but it is getting data crunched right now, and the source of truth should have much more higher frequency than what the end user is seeing. For example, we are totally fine to build up this aggregation in 1 day time. Then what will happen is actually the system has knowledge of like very high frequency, but the end user is seeing it via cache. So there is a consistency gap between the two systems, and we are totally fine as long as we are able to typically serve the end customer. So this could be one example where
what you've given, maybe you had something specific in mind, but I was expecting something clearer with a clear scenario. Let's say Bob makes a search for, let's say, rock, and someone else types rock. How does Bob immediately affect the search of other people?
Sure. So let me. Sure. Let me explain in that language, definitely. Alice and Bob is there. So Alice, recently got lucky, and she is searching for metaverse, and she is really hitting, 10 times a day or whatever, so that is from Alice's perspective. The system should capture this frequency of metaverse, and it should increase the frequency and weightage. But what is happening is Bob still for couple of maybe 30 minutes does not see metaverse automatically appearing in the Typeahead search. The issue is not in the system per se. It is the trade-off or the choice that we have made, that any of the results that the system has accepted, it will take a while to reflect it to the end user. So here what we are trying to optimize is that though the different parts of the system are not consistent, like cache may be a little lag or stale, the database may be less older, but the queue will have the source of the truth, and the clients who are making are the have the actual content, but they are completely largely out of sync in terms of the time domain. But at least we are able to
what I was expecting. What I was expecting here, you're describing a near real-time search that has high latency for the ingestion. What I was expecting when you talk about consistency for a search was Bob makes a search, exactly the same words. He has exactly the same settings as Alice, but they get different results. That's what I call inconsistency.
Okay.
You see, and I agree. It makes total sense that it. I wouldn't say it makes total sense, but personally, I think it's okay to be eventually consistent. Okay, which means that you can have different results per user. So I make a distinction between the eventual consistency and the high latency. Usually those are different things.
Yeah. Got it. So definitely you provided some good use of words, more simplistic and more to the point. So I was thinking from the implementation perspective.
And one point on the inconsistency, right, Shiva? If there is a eventual consistency, you need to think about how do you reconcile data. Let's say Alice and Bob both are searching and for one particular word, and the counter is increasing relatively different in different databases, right? And when you are bringing it consistencies to the same level, you have to make a choice. What is the latest data? I mean, of course, that will part of your design.
Sure. So I think that will come up as a more like a design choice. So if I go by a model where different users could have a completely different view of the system, or I could go by a model that the system has a repeatable read, whatever I am feeding the system, I may not be consuming then and there itself. So that would be kind of a choice. Then we can debate on whether that suits the requirement. So these are definitely two approaches that we can take. So we will at least debate on another one, but if we feel that a different snapshot could be relevant, then we will kind of debate on that. So I'll just in the benefit of time, I'll jump to the scaling. Is that fine?
Yes.
Okay. So So here, fortunately, I have already somehow captured that the scale of any Typeahead search would be 1 billion daily active users. So the intent here is whenever I'm clarifying the requirement, I want to use simple words like monthly active user, daily active user. And from there on, I would like to infer the next set of numbers rather than asking this all the details from the product, like directly asking maybe QPS or TPS. So here, 1 billion daily active user that we already confirmed here. Now each user can make up to 10, 15 or more searches. Like typically I have seen like weekly I'm making around 500 searches. So that is what is coming in my Google statistics. So that way I will have, if I make it maybe 700 searches, so that would make me 100 searches a day at my level. So so I'm taking that as a cap of this thing. So next thing is like that would mean that we will have close to 100 billion requests a day, or on an average 1 million query per second. So I'll divide by 100k 1L or 100k here is the formula I'm using here. And peak traffic, some places I've seen people are using peak traffic as 2x 3x. So just for safety I'll use 10x here. So that comes to worst case, like we will have to design for 10 million QPS. So does that sound fine from
that's fair?
Fair, right? Okay.
Any other feedback from anyone? Let's go.
Okay, cool. So so this is the QPS. So one thing I will make assumption here is because the read write ratio is almost like 10:1. So I will say the write transaction, basically the TPS would be 1 million. So sounds fine, right? And also I can use some other levy here during the write flow. So next part is storage.
Just something. It means that people, they get 10 times more suggestion than they search. I would be surprised about that. I think you're I know you talked about it earlier, but I just realized that I disagree. I think it's 1-to-1.
Okay, 1-to-1 would be more appropriate.
Because by definition, if you search, you're actually going to write into the system, right? If you search, you're impacting the suggestion.
Okay, so suppose I'm just writing the things like that. So I'm already getting so many feedback here. So what happens is I'm not using any of these feedbacks. Exactly. So that is the reason I corrected myself that whatever
you're right. Yeah, mistake on my end. You're right.
Okay. Cool then. So so that way I'll be and also like I'll be typing up to 10 characters, like 5 to 10 characters. So many time, even starting with lesser character, I will start getting suggestion, but I will not accept them. So that way I can assume that 1 million TPS should be fine. So I'll jump to the storage requirement here. So typically we can assume a search prefix from 3 to 20 characters length, and response can be 50 characters. So this is a kind of assumption. Anywhere we can definitely debate that, okay, maybe 100 would be a better number. And for safety, we will say that 2 bytes per character. So we can say that like up to 100 bytes, like request or response would be what we would need as part of the system design. Sounds fine.
What is the response?
So response, I mean, at a very simplistic level, the response will have the full, the search result here. Like for example, I say, meta, so it will have metaverse. So that's all. Yeah.
So now question, is this really stored, the response? Is it really stored somewhere in disk?
So what we
memory is that why you're thinking about that? Is because you want to cache this? You're thinking of caching this? Because spontaneously you could say, like without, like really naively, you could say, well, this thing can be computed on the fly. Every time you make a search, you get this response from the data structure you had initially. But I think you're already getting ahead, and you're imagining that this would be cached, right? The response.
Yeah. So what? So in a way, I'm just trying to think that what would be the disk storage requirement, what would be the memory storage requirement. So in that regard, I'm trying to come up with numbers so that I can fit some of these things here. So for example, the unique high frequency rate, this could be cached in memory. This is like jumping to solution, and this is something needs to be stored in disk. So this is again jumping to solution, but just working backward.
Are you going to store the response in disk?
No, not exactly. So we will see from solution perspective. So I'm right now just coming up with some numbers, like this could be a requirement that I have. This is the request size, this is the response size. So what will be the total goal here, and then we will see exactly, we will store it, or it will be too large to be cached. Then probably we can directly serve some data structure and things like that. So so here what I'm trying to make here is the storage requirement. Maybe okay, so we had how many, 1 billion. So I think some of the numbers may need to be slightly fine-tuned, because for 1 billion daily active user, I have 100 queries and only 10 accepts a day, basically 10 accepts a day. So that way what I'm maybe I was additional 0 here, because this is from the query, this is fine, but from the storage it will be just 10 billion would be the entries here. So it will be like 100 GB or 10 TB only. That is how I see. So this is basically the query part, and this is storage, so to say. So we will definitely get this level of request, so we can kind of with caching possibility. So this is what I'm trying to capture here. And the next thing is, does that sound more justifying here?
Yeah, it does. You can also mention that it's hard to have that estimations. You know why? It's because there is a lot of duplicates, obviously. The English alphabet or Indian alphabet or whatever is limited. So if you think about it, you have, let's say, imagine the prefixes are only of size 10. This is 26 to the power of 10 possible words, and that's literally your storage in terms of text, right?
Yes. Yeah. So I can put a kind of footnote, like there is a lot of redundancy here. So actual system, actual load may be much lower. Actual storage requirements may be much lower. So yeah, I'll definitely take that as a good feedback here. So so I'll just move to the compute requirements. So here what we
are seeing, that's fine. I think that's fine. We can move on to the high level design.
Okay, sure. Yeah. So sure. So I'll just jump to the high level design here. So this is like it will take like 10 minutes or something to prepare this. So so let's say that 10 minutes passed by and I prepared this as a solution. So I'll kind of highlight some of these parts. So first of all, my screen is visible here, right? Like it's good zoomed. Okay, I'll just zoom a bit more. So I'll just try to cover this, and maybe I'll just check back on my document if I'm missing anything here. So the way I would design the system is the users, like typically users, they will make a web call to the web server, and their response will be served via some word recommender service, and like whatever word we are feeding, it will go to some sampler and couple of other steps here, and finally build the system. So do you want to go and deep dive each one at a time? First of all, I should explain the big picture and assumptions, and then we can do deep dive here.
Yes.
Okay, so let me then first explain the big picture here. So the couple of things I'm seeing here is that I'm just making some assumptions. So one assumption is that we need not require to immediately process any of the captured or ingested words, and we can actually be a little stale on that. So a couple of things I will be doing is, first of all, I will be completely splitting the write flow and the read flow. So basically this is my write flow here, and this is the read flow here. So so that way it gives me a lot of leeway of independent optimization. So so I'll highlight on the read flow here, and I'll start with the simplest one. I will highlight the read flow and we can deep dive. Then I can highlight the write flow, and then maybe we can think if all these communications are happening correctly, if fault tolerance is getting covered, and then I'll be open for questions. So is that fine?
Yes.
Okay, so another thing is I'm just as part of this design, I'm building a batch kind of system. So is that fine? Otherwise, I also have a streaming kind of solution, but it will have completely different trade-offs and assumptions as part of this. So do you want me to
present the batch and
okay,
tell us the limits of the batch?
Okay, okay,
tell us present the streaming just concisely and tell us the trade-off between the two.
Sure, definitely. Thanks for the confirmation. So here, like I said, I'll be starting off with the simplest part, justify it, and then move on to the bigger pieces. So the very first thing would be the client will make a call to the web server. They will get the response built by the service, and it will be returned. So in typical format, we want that section to be, it should not be a full page load and things like that. So we can make an AJAX call from the web browser if it is a web, or we can use any other async.
That's fine. That's fine.
That's fine, right?
Let's assume we did the query.
Yeah. So now how the query will be served. So what I'm thinking is that the very first thing is, can I cache these results? So maybe I'll have to a little bit see here. So here, yeah. So what I can do here is simply whatever are the frequently fetched items here. Like suppose the keyword is metaverse, so I'll definitely cache this as a request response format in any distributed cache. So so I will definitely make sure that everywhere there is a load balancer, and there is some sort of auto scaling, and replicas will be there for the service, the web server, and of course the DB as well, so that we are sure that the fault tolerance, the high availability kind of guarantees are met. We will come to that part again. So the very first thing functionally would be that whatever request we fetch from the DB, like there will be one active DB, so it will hit some cluster selector, this service, and it will get the response if it is not already cached. So what we can do here is, to prevent the staleness of data, we can set some sort of TTL. So we can have maybe 30 minutes TTL. So after every 30 minutes it will expire, and it has to be fetched from the DB. So so we can also synchronize this with the batch format. Like for example, if this batch is getting updated every 1 hour, then I can increase the TTL to 1 hour to match up with that frequency, so to say. So now so couple of things, the trade-off I'm making here is, one thing, I'm losing a little bit of consistency, but definitely I'm able to make a high availability, because I'm using in-memory kind of cache here, so that will be much faster than retrieving it from the disk. Yeah.
I think there is a problem, which is the problem you usually have when you present something that you've worked on before. It's that it's an optimized solution, and so you don't immediately see why all those components are here.
Yes. Okay. Sure.
I'm just gonna try and quickly try and understand what you said. So you do get suggestion is going to pass a string. Let's say I'm searching for cat. Okay.
Yeah.
It's going to go through the word recommender service.
Yeah.
That's what you're saying. Okay.
Correct.
And this word recommender service, is it it's just a service that will write into these frequently fetched items?
So this is basically the read flow. So for simplicity, I've chosen the read flow.
Okay, it's going to read from the frequently fetched item, and I'm assuming you're going to show us the design of the frequently fetched item later, right?
Yes. Okay. So yeah. So this is just for simplicity, I'm talking about the read flow. So for completeness or cohesiveness from understanding perspective, let me now jump to the write flow, and then maybe we'll loop up again. So what we will do is, that definitely this is a very high throughput system. Like we are getting close to 1 million write TPS. So, and a couple of leeway we can do is like the consistency part that we were talking of. So what we will do is that whatever requests are coming, we will batch 1000 those accepted or ingested words, and then we will kind of pass on that final accepted words, and then we will have some sort of word sampler. Like probably we will take only 10% or 1% of that request, because very low frequently word, if we are putting it to our type ahead search system, we are unnecessarily trying to capture the long tail. So we will have some threshold. So this will be a heuristic threshold, like we can agree or on some other number as well. So this is like top 1% over like frequency. I will sort, and then I will send that via word filter. So here what will happen is any bad words or something like that is there, then I don't want to capture as part of my good search engine, and I will filter that. Basically I'll sample that as part of this worker, and then I will filter those words, and then I will aggregate those words. So what does the aggregation mean here is that suppose as a stream, like 100 words arrived, and now many of those are like highly frequently occurring, because I'm already sampling and I'm just taking the top frequent words. So one of the words like metaverse will have 10 frequency. So instead of passing it to raw, I can probably aggregate this as a metaverse 10, and then I can dump it to hourly bucket. So what this will be the write flow, which is an independent flow, and this will make sure that in that hourly bucket I have all the data available, readily available, and it will be like it will provide a very good amount of durability, and it will make the two systems completely independent in terms of kind of access or scale, so to say. So this will be the right flow. Yeah.
Sorry, I have a couple of questions here.
Sure.
So when you say so the word aggregator, so you mentioned that it will just aggregate counts of batched words, more or less like a reduced stage of map reduce. That is what you are describing here, right?
Yes.
So if there are, okay, sure. So I think, can you maybe clarify exactly what you are going to be storing in the end? Because are you just going to store metaverse 10? Or are you going to store MET10, META10, METAV10? Because you have to be storing the prefixes, right? It's not
sure.
just the word, it's the prefix, right?
Sure.
Is that right?
Got it. So it should be something like this, that when I type met, it should be the metaverse, and 10 frequency we achieved. So for the word metaverse, we are definitely capturing the 10 frequency now as part of that full solution. Like if we end up using try, then this will actually impact rest of the rest of the parents as well as part of the decision. So typically the metaverse 10 frequency would be useful, but I can capture the prefix word here as well.
Just to clarify, right? At some point, so I'm not saying you should not store metaverse 10, right? It might make sense for you to store metaverse just the words at this point, or just the queries at this point.
Yeah.
But then at some point you have to also convert those words to prefixes for easy retrieval.
Sure.
Right. So there is some place in your entire system where you are going to store all the prefixes and the frequency of the prefixes. Is that bucket the place, or is there somewhere else? I think that was my question.
Yeah. So a bucket will only capture raw data. So it will only have raw data, raw ingested data only, and it will not think anything about the final data structure. So final data structure, the intent is that can we we will actually use this DB for capturing the final processed results. So
and who is doing the processing?
Yeah, so the processing part is we will have some sort of map reduce job, which will on hourly level, it will take this raw ingested partially, partially aggregated data, and then it will update, it will basically update this data store. Yeah, so it will basically fetch the raw pre-aggregated data and then update the DB with final results, like final results for immediate consumption. So we will see what could be the solution, and we can debate on that. So this is largely the high-level system that I'm thinking.
One more thing.
Yeah.
So I think I have a question about the hourly bucket as well. So how is the hourly bucket going to look? So is it going to be a set of files? Or so for example, you can expect certain words for, let's take metaverse, for example, it will keep on getting fixed throughout the day. Right? So is there going to be one entry for the word metaverse in that bucket? And then you keep on writing on top of it, or do you create every a new entry for metaverse inside the hourly bucket every hour?
Yeah. So
do you see what I'm trying to ask? Sorry. Yeah.
Can you just repeat? I certainly got lost.
So I think so. I am trying to imagine how the hourly bucket would look like. The storage for the hourly bucket would look like.
Yeah.
So there are two ways I can imagine, right? I can imagine either a key value store or a simple SQL database where the key is the word that is or the query that has been searched, and the value is the count for the number of times it has been searched total. Right? That is one setup. The other setup is, since you say it is an hourly bucket, it could be something like, okay, for this particular hour, from hour number 10 to 11, meta has been searched 1,000 times. And then there will be another row for meta for a different hour. So what is it that will actually go into that hourly bucket?
Sure. So let me detail that out. So in this hourly bucket, what will be there is like we will have, suppose for simplicity, like it will be mm/dd, and then it will be hour. We'll just keep hour. Okay, so inside this bucket or folder, we will have now file 1, then we will have file 2, file 3. Okay, so what these things will
so for every hour you will have a file, and that will contain the counts of all. Okay.
No, not there yet. So what will happen is these files, these files will actually, I'll just zoom in on the file. So the file will have frequency of the last batch, basically. So let me just, so it will be something like this. So it will be metaverse 10 frequency. So this is the file 1. So now what happens is, so when I'm doing any aggregation, it immediately, whatever is the data that is part of that mini batch, it will just go and dump it here. Then the same thing could happen again. Like I'll have a similar thing could happen. Let me just increase the size. So I will have file 1, I'll have file 2, and this file 2 will also have met so it could have meta as metaverse, and it will have maybe 100 frequency. So the intent of this is as frequently you are getting all the data, as almost like near real time you are getting the data, just go ahead and dump those frequency in the specific hourly buckets. So the purpose here is that I don't want to wait for the full hour to populate, because it might lead to memory overflow in these workers, and it could lead to also durability issue. Like if I wait for 1 hour to finally then populate, then it will be a durability issue for that metaverse frequency. So as and when we are getting the frequency as part of that mini batches of maybe 1 second, it will just go ahead and update it here. Now this Spark job will then take read one of these buckets. It will see multiple files having multiple frequencies of the same words, and then it will aggregate again and kind of here, the aggregation will happen, and it will just, directly have a frequency of maybe, I mean, just for simplicity, I'm saying that metaverse will have, 110 frequency here. And that is what I need to update to the DB. So here, this will be aggregation over aggregation. So this is like update to the DB. So yeah, so this,
So I think no matter what you do, a lot of participants, including me, will always ask questions about this design. And also question it. For example, the fact that metaverse maps to, that met maps to metaverse. It could map to many things actually.
Yes.
The truth is, let's talk about this this data structure that you search against. I think it's going to be interesting to talk about that, and then we can move on to that again, how you ingest into that data structure. So what's the data structure that allow you to search? Let's say I'm looking for, let's find a word that makes sense for you. You mentioned metaverse. Let's say I'm looking for meta. Okay.
Sure.
Or so whatever you plan to present to us the main algorithm of retrieval.
Sure. So what I'll be using here is I'll use typically a tried data structure would be very kind of useful or relevant here. So it allows so the purpose of that data structure itself is prefix search. So now, for example, I want to capture the meta part here. So I'll have something like ME and then T, and then there will be certain frequencies associated with that. So the very simplistic model, I can just say that at each terminal level, I will put some frequency here. So this is so this is actually for Met, this is a frequency. For metaverse, it will go longer, and so it will go on, and then for the final word, there will be a frequency of that specific term. And now what I will do is, for additional efficiency, I will whenever, so what I will do is, for example, suppose I got 110 more instances of metaverse here. So what I will do is, suppose that metaverse in summarized way is suppose Met. So first thing first, I will go ahead and add that frequency here. So what will happen is this will be this plus 110. So this will be the very first thing, and the next thing would be it will go bottom up, and it will pre-cache those results for the top 10 results at each level. So what will happen here is that as part of me for the metaverse, I will say that I have this frequency, basically 1110 frequency. I have metaverse here, and for then there will be other words as well. But suppose for starting with M, we will typically not cater to this level because this will be very inefficient and less fruitful. It could be just 1 million, and this is just about me. Okay, just a stupid thing. Just me is a thing. So here, or I'll just take my just so that I don't confuse here. So this will take precedence over metaverse here. So metaverse would be like 1110 frequency would be metaverse. So what I will do here is, whenever a user types in a word, for example, I just type in M, so it will check the already pre-cached, it will have 10 pre-cached results here, built bottom up. So it will just look up on that, and it will respond with those results, and my client will be smart enough to just take up 5 of them or 10 of them, or things like that. And so this will be basically the try data structure that I will be using. So any other question? Okay. Do you want me to deep dive on this?
So now let's challenge this design. Tell me how you solve this issue. You told me you were storing 10 results in one node. Let's say M will store the 10 most likely results. For example, you store M, you could store metaverse, me, mommy, whatever. Okay, great. You store the 10 results. Now, let's imagine this fictitious 11th result. Let's say it's a man, okay?
Okay. Okay.
It turns out during the man's day or whatever
Yeah.
day it is, people search more for man, and this guy becomes the 10th result. How do you
Yes.
handle that in your data structure? Because if I understand, M maps only to 10 results. It doesn't give you the count of man. Where is the count of man?
Yes, surely. So I'll talk about it. So it will look something like this. So we will have MA. I'll just try to quickly draw this. Something like this, it should be sorted. So suppose in typical setup, yeah. So suppose in the typical setup, the significance of man is very less. Okay, just on a lighter note. Okay, so this is just 10 here. Not many people are looking for man. So this is very low frequency, and what will happen is that very infrequently we are getting one instance of, okay, I want to search for men for whatever like trimming my beard or something not in November. So it will just come to 11. So it will not be able to compete and race up with my or metaverse here or rest of the 10 items. So it will of course when I type men, it will return men. If I type maybe MA, assuming that there at least the significance of men is there, so it will be coming up till this level, but not beyond this. It cannot compete with my or metaverse. They have much more frequency or relevance. Now what happens is yeah, so during I think some November some theme Western, yeah.
So for every letter we are typing, we are going all the way down to the terminals of terminal words and trying to get their rank. Is that right?
No. So what? Yeah. So let me explain that. So there are two flows where how we will play that. So in the write flow, what we will do is we will go, we will search here. So write has some level of latency and all, right? And so what we'll do is we will go all the way till the terminal node, and then we will first of all update the frequency here. So it will be like men is like it was 10, and then I add 1 here. Okay, so this will be updated as part of that batch job, and then there will be another algorithm that the very next step, it will propagate that change to the top. So some sort of maybe yeah. So for example, here the term this terminal suppose this was not but metaverse here. So this will pick up this frequency, and it will see that whether I'm able to compete with top 10 results of my parent. So if I'm able to compete, yeah.
Basically, every non-terminal node gets updated, right?
Yeah. So I would say every parent nodes get updated. So the steps or the algorithm will be like this. I will just make it like this. Yeah. I will as part of the write flow, I will.
So you don't have to do bottom up, right? You already know the word. You already know what the frequency for the word would be. So you can do top down. You don't have to go all the way up and then go back following the parents, right? So you can you already know metaverse is the word. So why do you need to do bottom up? I don't know. So you can just do top down. So you already know metaverse is the word, and you know what the frequency is. So all you need to do is at every single node, just update the count if that word exists. If not, keep moving down.
Yes. So if we actually, so if we are able to break it into two step very precisely, like for example, just I write the aggregated result here, and then I do a fetch of this result, or because maybe I will do some increment operator or something like that. So I may not have full context of what is the actual value that is stored in this node. So there are two ways here. If it is just a single system or single algorithm where I go ahead, update this value, and then I propagate it, then I will have to go bottom up. But alternatively, I can go do top down theoretically, where I update and then I fetch the value, and then I go from the top and I keep updating the nodes. So typically, I think for me, from algorithmic perspective, at least from that priority, bottom up sounds intuitive from that thing, but I think both will work. Just for
is my understanding correct that the word, so you at every non-terminal node you are caching every top 10 results, right? So if you know that the word that is going to be inserted into the try is metaverse, then you would know even in the top node that metaverse is in the top 10 for M. So you can update it right there. And then in the second node also a metaverse is there, you can update it right there. And in the final node also metaverse would be there, you can update it right there. And then you don't have to do another traversal from bottom to top because you have already updated while you work your way down.
Yes, I got it.
That is, so that was what I was trying to say. But that's okay. I think what Yande asked was interesting, right? So how do you insert a new result in the top 10 when it gets when it changes position from 11th?
I think he answered. I think he answered. Let me attempt to try and explain what you just said, because I think you just answered. What you're gonna do is, there is man somewhere in the terminal node, and this man is updated every 1000. Let's say you said that there would be a batch. On a batchly basis, it would be updating your full try. What you're gonna do is, on a batch based again, right? You're gonna take this man here and look at its parent and see if he beats one of the nodes being cached. Is that correct, what I'm saying? So for example,
yes, correct.
You're going to take man and you're going to look at M and you're going to say, hey, man is, let's say 325,000. He beats 320,000, the 10th word, he beats him. Okay, the 10th word is out and it's being replaced by man. So is it fair to say that, and is it done on a batch process?
Yes, correct. Yeah. So what will happen? Yeah.
And tell me, is it happening synchronously when you update the try? You mentioned that you would update by batches of 1,000 words or whatever. Is it happening at the same time or or in another schedule?
So that is in another schedule. So the ingestion is happening in a batch of 1,000 for network efficiency. So here, we will use some sort of map reduce job mechanism. So the concurrency, we have to see that two people, if they are trying, how do we cater to the concurrency part? Probably I haven't thought of that much. But for simplicity, I can say that word by word, we can take up that word. We will sort that here. Like I will see with the parent, and this exceeds, like 10K was added here, so it will become something like 10K here, and this will then replace the metaverse here, because men will have much more frequency than metaverse in a while. So this will come here, and maybe if this metaverse go to the 10 beyond 10, it will be dropped as part of this. So so we can optimize from the algorithm perspective that we can batch 100 words together and then sort them together. And some of the time, if they are conflicting or competing with each other, our algorithm will have to make sure that it can run concurrently. So that will be more deep dive required on how do we write that specific map reduce job, so that two people on the same tree, if they are trying to optimize, probably the correct sorted order should come here. So yeah, intent is the same that you are saying. Yeah.
Okay. So what we can go ahead. Sorry.
I have another question related to. So we definitely talked about try, but then I'm not following how. So in the read flow, you said you will just use some database to get the data, but then now you are talking about try, which seems like a lot like in-memory representation because you need pointers. So how does it work? I still didn't follow fully.
Sure.
Yeah, so how do you make the try? So are you trying to write the try into a database? Plus, we can talk about the latency requirements later, but this whole thing I am not able to fully connect. Sorry.
Sure. So what I can do here is definitely let me connect those dots if I have it here or in the document. I'm just jumping just to see if I have.
You have a cluster selector and you have a passive and active, which seem like a database. But how do those work with the try?
Sure. So I'll do the deep dive. So let me explain the high level thing, and then definitely the very next thing I'll do the deep dive. So what is the choice here is that the serving traffic, basically the serving layer will use the active server, which is only used for typically the missed results that were not already cached, and there will be a passive data, and we can have both replicated just for the heck of it. And so here the passive one, all the writes will happen. Now how exactly that will be stored is we will have to go to the data store kind of choices there. So the very first thing that we are seeing here is that we want very high throughput, and another thing is that the read and the write flow. So the write flow has a lot of steps, definitely, like do this, then do this, then do this. But anyway, we have that latency level is there in the write flow, and we have like map reduce jobs. So a lot of things could theoretically run in parallel, so should not be an issue. So, and on the read flow, what we will do is that any of the keywords that are coming to us, there will be basically we will use some sort of hashing. So for example, like I want to search for met. So what will happen is that node, it has to land to that node. So so using met, we can hash, and then we can land to a specific row entry in this data store. So, so that could be one of the strategies. And if we want to choose any data store, so definitely we are not building a very highly consistent system. And so we can definitely, we don't need to choose a relational data model with a high transaction guarantees and, strong consistency and things like that. So what we can do is we can use any of the NoSQL DB. So there could be two choices here for storing the data. One could be like, yeah.
So before we go into NoSQL, right? So how exactly, so let's say we are going with any NoSQL database, how exactly are the data stored? So you have one row per prefix. Is that what you are trying to say?
Yes. So that is what I'm proposing, that one row
and
per,
the value, and the value would be the list of suggestions, comma, their counts.
Yes. For caching purpose. Yes. So that is what I'm thinking. So yes. So we will have that.
Shiva,
Yeah.
Shiva, like, this is just, out of the bond idea, right?
Yeah.
Let's say metaverse itself could produce how many letters, like 7 letters, but the possibilities are 7 to the power of 26 or something, right?
Okay. Yeah.
So it is too much of data. So I'm just giving it a thought. Is it possible to chunk the data of whatever starts with M into multiple pieces, and only that section will be loaded to a different server? Basically the worker nodes in your thing is like recommended service, right? Word recommendation service. So if it can point to the in the database, like somebody is asking, like how do you really take that that much data into the memory and calculate it, right? Can you give or chunk the one particular letter into multiple pieces, and give that responsibility to these multiple worker nodes, and can kind of use the saga pattern or something on top of it, right? That way we are not loading everything onto one single server, because you'll run out of memory at one point.
I would just like to say that it's not completely obvious that you run out of memory, because it's a really specific use case where we work with English language, and you actually might be surprised about the size of this data set. If you only store words and not sentences, it could actually be pretty small. But I agree, probably sharding here would be interesting, and to shard by start of a word, maybe.
Yeah, sure. So so we can definitely do that, and kind of I'm more explicitly documenting it here. So
but then why do you need to shard? If you said you will use NoSQL, right? So wouldn't the NoSQL database manage the prefixes themselves?
Yes, yes. So basically, I'm explaining from the concept perspective. Now the implementation could very much it could vary. Like if I'm using Cassandra sort of model, then consist with consistent hashing and all, it could be automatically self-managed sharded. But if I'm using Redis, I will have to manually shard. So so that is what at least in the design we'll have to think that
And
okay
one more thing about the storage, right? It's probably just what I'm just wondering out loud. But then in the write flow, you are doing write for every single prefix possible, right? In the last 1 hour or so. Is
yes,
that right?
yes.
And
So
that would be
no,
a lot
not
of writing, don't
exactly.
you think?
No, not every single prefix. So what I will do is suppose this is already December, so that November, whatever, blah, blah, man thing, it is not very frequent, and only metaverse is the hot word. So what will happen is we will only visit, this part, we will visit this and this. So only this frequency, will be updated as part of that,
No, you should
hot season.
update. You should update all the words frequencies, right? Otherwise, how will you know whether one word is close enough to overtake the other? So technically, you should update the try for both all the words that you see in the last hour or so. Don't you think? Otherwise, how would you
Yeah,
know?
yeah.
Don't
So
you
by
think?
all the words,
Yeah.
I mean here that I mean I understood is all means all in the try, but all you mean is like all that is seen. So definitely all the seen words will be updated for sure. Yeah. So
Not just all
I'll
the words, but all the prefixes of all the seen words, right?
yes, yes. Seen words and prefixes would be updated. So I'll just
So
not use
he's
all.
asking. I am not sure I understand your question. Can you rephrase it? My question was essentially how many writes will go into the write flow. Now, my understanding of what is going on here is that we will take the all the searches that we got in the last hour and we run a batch job every hour and update the try. In our case, the try is just a hash map of prefixes. Now, what we do during the writes is that we take each word that we saw in the last hour, look at all the prefixes of that word, and then update the prefixes if it exists in the try. That is my understanding of what is going on every during a write flow. Is that right?
Yes, yes, exactly. That
Yeah.
is what is happening. So initially I got confused when you say all word. So I was just thinking, are we visiting all the try, because that would be very explosive. So that's why kind of I'm keen on skipping the all word. I will just say seen words and prefixes would be updated. So I think we are on the same page, just that all word
Correct.
could be more confusing
I
rather
still
than
think that would be
clarifying.
too many writes, especially because you are putting it inside a persistent data store, right? But yeah, I guess
But
we have to
here I would say
maintain that.
I would tell my interviewer what are your expectations in terms of near real-time search, right? You can always get away with that because it's not user-facing. Those writes are happening offline, so you can always like say, hey, that's fine. We know it's a lot of writes, but unless you want me to do like near real-time search, I'm gonna move on and just assume that it's
Okay.
okay as a design.
So the one thing that I'm concerned about is that we use the same data store for reading the data as well. So no matter how, whenever you write, you are going to hog the database when you are reading from it. I think that is where things get a little tricky, in my mind at least. I don't have
Absolutely,
a good solution. But yeah,
I
so I
know that.
think no matter what you say, you are at some point doing lots and lots of writes whenever you run your batch job. That is going to affect your performance. And I don't honestly buy the idea that you can have 100 millisecond latency if you use a persistent data store. I think the lookup should happen for 99.999% of the cases in memory somehow. That is what
Oh,
I personally think.
yeah.
But yeah, I think those are good pros and cons that we can discuss during the interview.
Yes.
Sure,
So
sure.
Sriwas,
So
May I
do you
offer a
design?
suggestion? I believe like we should periodically compute that, like build a try and store it in the word recommender service so that we never really hit the database. So if we can compute the try, let's say,
Yes.
every 10 minutes, again, the frequency is something for discussion with the interviewer. But rather than you hitting the active database, if we proactively can build a try periodically from the active database and store it in the word recommend or in the cache or the word recommender service, wherever, and use that for serving requests, I would say that would be much better. No need to relay the read traffic to the active database.
Yeah, so it is possible with this design, right? Because the hourly buckets are just files that give you the latest counts of all the words that we're seeing. So maybe we can process those files and make them write all the prefix counts and let the word recommender service tail those files and load them, in memory. So when a word recommender service comes up, all it does is reads a snapshot file and keeps on tailing the list of hourly updates. And whenever an update comes, it just keeps reading in the background and then quickly updates its in-memory store. And that way, it will always keep the count. If the memory word recommender service goes away, it can always come up and read the files because the files were written out by the hourly bucket processor. I don't know if that makes sense, but yeah.
I have one more question. If you could elaborate, like which type of NoSQL store were you planning to use? Was it a document or a key value or a columnar? Can you expand on that?
Sure. So I think we have a couple of open questions here. So the very first one I would like to answer here is that when we are saying that there will be definitely a lot of high write throughput, which might impact the serving traffic. So for that purpose only in the batch model, I have separated out the read and the write flow. So the active database will be like 1 hour or 2 hour delayed, and it will just read the row that it is supposed to. For example, I'm just typing ME and I expect metaverse. So it will just create a prefix or a hash from there, ME, and it will try to fetch from the active data source. So what will happen is on the first instance, there could be a miss. So that 99.99 percentile one, it will be a miss. Basically, I'm just taking a reactive approach right now. We can have proactive as well. So it will be a miss. And after that, it will be anyway cached for 1 hour. So that way, rest of all the requests will be served from the cache. So my understanding is like any good cache, like if you are using, if you are using any good cache or in memory, then it can serve in 1 millisecond latency, and end-to-end latency also. I think theoretically it could be possible in 10 millisecond, not even 100 millisecond. So now only the worst part is if we are not able to fit in the data in the cache, then it has to hit the DB. So the good part is the write will not be impacting the DB because the write will happen to the passive data store here. So this is to answer the very first question where there could be very high throughput and how are we handling. So another thing is we are doing a sampling of 1% high frequency items only, so that we cover the business and don't cover really weird things like items I'm searching online and it does not have any financial or significant value, so that all those long tail would be just kicked out here. So top 1% frequency, high frequency item or something like that, I can have some sort of that kind of model. So this way we will reduce the effective scale on the system, basically the backend, the load on the system. And because this is an asynchronous model, so we can have some sort of, definitely it will have load leveling. It will write at certain rate only. So at fixed rate it will write so that the DB does not die. So we will have some sort of mechanism here that just write at fixed rate. Maybe suppose I have any data model choice, whatever X is there, and I did a benchmarking and it says that 10K TPS is just fine with me. So now my requirement was that I wanted 1 million QPS coming, TPS coming here, right? 1 million was the TPS that we were targeting. So here what will happen is, because of sampling, it will automatically convert to 10K here, and we will be doing a lot of aggregation as well. So theoretically what I'm seeing is it will easily fit in this fixed rate. So maybe an ingestion rate of 1K per second should also do, at least from my theoretical calculation, because we are doing a heavy sampling here. So if we adjust any of these, so we already have a lot of leeway here in the write flow. Now, if we go to the read flow, like I said, there could be, reactive or proactive model. So as of now, I have just designed a reactive model that on miss, you go ahead and hit the DB, and then get the results transferred or cached to here. So this will be like frequently cached raw item that will be available here. Now I have another proposal which is more useful in, if we are designing a real-time kind of system. So there my suggestion is, whenever any writes are happening, can we directly probably write to the cache itself, with a rate limiter, write to the cache, and from the cache it will be a write through to the DB. So all the hot items will definitely be there in the cache, and we can have TTL or a frequency based model through which the data will be always, the hot data will be always available in this model. So I think for 99.9% guarantee of low latency, this model would also work. So I will not over optimize complicating this thing, because then this will become a bottleneck, especially for this design, that too many writes happening to the cache and also read happening to the cache. So it will be hard to provide the fault tolerance. Basically, could go for a toss. So this is a design where I'm trying to leverage, partition all the systems into separate components, or maybe like ship bulkhead, and just take care of their optimization and resiliency, so to say. So I think this should do for the purpose. So does that sound good? Then I will go into the database choice here. Does that sound good, that I'll mess on first part and then fetch from DB? And so this is typically a design choice in any of the caching model. Yeah, sorry. Yeah.
What we're going to try and do is close the interview in 15 minutes. Okay.
Yeah, sure. I'll abide to that. Yeah.
So you can, since I know that we're going to have a lot of questions, what you can do is like finish now.
Yeah. Sure.
And then this will leave us sometimes for questions and then details and all of that. So just conclude what you had in your other web page, whatever you wanted to say, to mention, things that you would have talked about if you had more time.
Sure. So in this model, I'll choose this where these are certain justification, and on a miss I will do this. So now I'll jump to the document and try to see whatever I can present quickly, maybe next 10 to 15 minutes. So this is kind of a request query that I am thinking, and this will be the accepted response that I will return to the backend as part of the get and post, or maybe using some Ajax model. And since this is not a backend system, so we will try to use more interoperable REST API rather than gRPC and other systems, which will make the compatibility more of a challenge. So now, this was the older design here. So I'll just so now coming to a couple of things. Actually, there were already some clarifying questions asked by some of the people. I had presented it at another platform. So I got some of the things, like some people wanted that what if I want real time, what if I want batch. So this is basically the batch kind of solution where a little bit of lag is fine. And this is kind of a proposal, like a little sketchy proposal, where immediately whatever results we are getting, we can probably put it to cache, but scaling this could be a challenge. That's why I'm not proposing it a first class thing. So another thing is like, what about the multi-region support? So as of now, we haven't thought of a multi-region design here. So what we could do as a very trivial solution could be that each of the region, we can have a completely isolated system in the different region, and just deploy different pipeline, isolate from each other, and we should be fine. for most practical purposes. But another thing could be that everything will be served from a single region, and the region-wise replica would have like a little lag, whatever is going from here, it will be copied to the other regions, but they will have little lag. So it has a completely its own set of nuances, which will go for maybe 10 minutes of discussion. So I'll just skip that part. So it could get accepted in US, it could get replicated in other region. So another interesting question was, how would you accommodate for personalized prediction? So this was this was kind of covered here. So we can have a separate microservice backend backed by cache, where we would do personalized prediction. So the way I see is, like, for example, when I say the hard, so whatever, like I'll just put like this. Yeah, so probably I had searched this book, the hard parts, Neil. So this is something we can do. Whenever we are hitting this word recommender service, it will also have personalized service, something like this. So what it will do is, it will check if it is already a part of personalized request, and if it is already there, it will prioritize between the two, and then it could return. Another thing we could do is, if there is a personalized request response that we already had searched earlier, we could also probably cache it in our cookies or results. So this could be so this could be a separate service. This could be cached in browser as well, because this will be very small thing, like maybe my 100 words that I searched in last 1 month or something like that. So, and we can again, for scaling purpose, we can shard it by IP. That way, if we are storing anything on the backend, probably we will fetch it from the specific DB for this personalized, for DB and caching needs. We can have this kind of sharding. Especially to prevent the hot DB or hot node kind of thing. Another thing we could do is probably if there is an ask, that we can have some sort of additional weightage multiplier in the try, like noun could have 2x multiplier, verb could have 1x multiplier, adjective could have lesser multiplier, because that will not add value. So that way we will pull out the result while building the try that it is ending to a noun, then we will just multiply by 2 or something. So this is something that we can do as part of this thing. And now this was the data source. So now going back,
just one thing, I see that you are at the middle of your web page.
Okay. Don't worry. I'll just maybe give me 5 minutes. So the thing is that regarding the choice of data store, we can definitely choose any high write throughput data store. So that could be at the scale like 1K QPS or 10K QPS. A white column, or I think anything could be just fine. So white column or columnar data store, it actually provides very high throughput. So we can leverage that because it has write ahead log. So we can leverage that, and it also provides caching out of the box. So frequently fetched rows would be available here, so to say. So that way, I think I'll go ahead with a white column because the next thing is here I want key value pair. So if I just keep the same thing here, probably I'll not get additional benefit of caching here. So that is what I'm thinking. Another thing is, typically the white column data stores like Cassandra, it provides durability out of the box. So if I choose key value store like typically Redis, I will have to think about persistence. I could choose React, but typically the key value stores are more optimized for read and typically in memory, and the Cassandra white column are more optimized for writes. So here I could choose column DB here, so to say, and here I can choose key value store DB to justify the requirements. Now I'll kind of in 5 minutes, I will wrap up. So we'll definitely have separate read flow. We will have separate write flow. We will have cluster selection that we already discussed. And the data structure, the algorithm we will be using is try that we already discussed, which is prefix this thing. We can have this kind of model. We can simplify or enhance based on the needs. And we will now kind of close with some of the component trade-off or resiliency and component trade-off. So the very first thing is latency. So we are already using the key value pair to achieve low latency for caching, and we are assuming that we will have at least 99% caching, and that could also like help me with 10 millisecond latency for at least those traffic. So the purpose of 100 millisecond could easily be met here. That is what I'm thinking. So no value key store like Redis or anything we could use, like Dynamo and all as well. You could use based on like if you want to use a serverless kind of solution. So scalability we already talked about. So typically scalability, how I'm handling here is that I'm separating out the read and write flow. If it would have been the same flow, then the same DB could become a bottleneck. The hot nodes while writing could become a hot node while reading. So there will be a lot of contention here. For availability, high availability, I will be using replicas, and definitely the write ahead log that will be provided for durability will also provide me the high availability. And another thing is I will be using some sort of object store or data lake, whatever we call here. So this object store will have like really high durability of maybe 699 level of 9. So that way, even if my whole system goes down, I have all the source of truth available here. So I can rebuild everything in a matter of 1 hour, because this is my bad job. So this, but if any of these things, and also here, suppose my active replica is gone, then I can switch to the passive, and that way also I can recover much easier. So a lot of recoverability has been also built here. So that recoverability will provide me higher availability. And couple of things I will definitely optimize as part of system resiliency is I want to prevent the system failure due to excessive load. So I'll have as a downstream, I will have some sort of timeout so that I unnecessarily don't wait for the API. I will have some sort of retries and circuit breaker. And at the system level, I will have some sort of load shedding. Like whenever any of the system is becoming hot, probably I can start dropping some of the traffic. It should be totally fine if I'm not dropping any of the client traffic, but any of the write, if I'm dropping, I think I'm fine to large extent. And load leveling we are already using, and some of these things we are using. And for recoverability, we'll have monitoring health check and things like that. So largely this covers this. I think this is just a space or something. I don't know, some dead component here. So I'm done here. Maybe it is some dead component. I'm not sure. Right. So yeah.
So let's spend 5 to 10 minutes on questions.
Yeah, sure. Yeah.
And the questions can be answered by you or by anyone from the group if they think they have the answer. Okay.
No. Great. Thanks. Yeah.
I have one question. Can someone comment on what are the other cons of going with the streaming solution? Like in an interview, which one would you ideally go with? There are 2 solutions, and I agree with this solution, but I just want to also get a better sense of the trade-offs that we are making. Like, why not go for the other streaming one?
Sure. So I will start. Maybe people can add up to that. So that sounds fine, right?
Yes.
Yeah. So the very first thing of the streaming solution is handling the scale. So what I feel like, the writes are happening at the same time, the reads are happening at the same time. Many of the systems are becoming bottleneck. The DB is becoming bottleneck on the read and write flow. Cache is becoming bottleneck. What if suddenly a lot of read traffic comes and that also percolates to the write traffic almost like immediately, and due to that 5-minute spike, everyone is sitting on top of all these systems. Everything is red. So the very first problem would be handle the scale, especially the spike, the elasticity would be a challenge here. That is what I think. So regarding just this specific point, anyone would like to add something here? Maybe then I can jump to some other aspects.
No, that's fine. And I think we can do more of a rapid fire questions. Yeah, but I agree with you what you say. Streaming if the interviewer wants his real-time system. Otherwise, we go for the batch, the simplest one and the one that will be the easiest to build and doesn't provide bottlenecks.
Yeah, sure.
Do you have anything else to say?
Yeah, sure. So maybe one or two points I will add. So another thing is that because we are building a streaming system, fault tolerance would be much more critical here. Like like we have any part of the system goes down, it will immediately impact everything. Like my write flow is very heavy, it will impact the read flow. Like the concern that was raised maybe 20 minutes back, that similarly my cache is getting filled up, it will impact both the guys. So I think and the third thing would be complexity. So these are the things I would point before we jump to streaming solution. Though streaming would sound more awesome, but it would definitely be much more complex to create, maintain, debug. Yeah, so that's all from my side. Anyone else would want? Otherwise we can jump to another question.
I have one question.
Yeah.
How are we going to achieve high availability with the try? Let's say if the node that is having the high dice.
Sure.
Yeah.
Sure. So so high availability would require the very first thing would require is a replication, and to handle the load we will require the sharding. So for the replication, what we will do, especially so are you specifically looking for the write flow or read flow? Because that is what I'm leveraging here a bit.
I'm more interested how the try gets rebuilt on the other node.
Oh, okay. So on the write flow, for the high scalability, I think we have a lot of leeway. At least from the calculation, do we really need 1 million TPS here? Probably we don't. That will be unnecessary, waste of machine resources. So the way from my calculation, we should be able to live with 1K event injection per second. So my question would be, do we really need high throughput in the write? So no. So now we can think that, okay, what high availability? So for the high availability, first thing first is because there is not much load, typically any sharded system or NoSQL system, like I said, like it can easily handle, like maybe Cassandra can handle maybe up to easily I think 40K TPS here, and Redis can handle up to maybe 1 million TPS here. So because none of these are actually hitting this system, so there are chances that the system will not go down due to the load. So what lies here is only the replication. So replication of the instances would just suffice, is what I believe.
Your question is about the read or the write? Because the write, since they are offline in the batch system, I don't see how they could be an issue for the load. What was your question for the reads?
His question was on write. So typically the availability of on write is not a big issue that I would point when compared with the read flow. So read would be more significantly important in terms of availability. This could be once in a while, if my passive DB is overloaded or down, how I would achieve high availability is I can follow some of these paradigms, like a bit of load shedding I can do, like my DB is getting overloaded. So so first of all, let me clarify by availability. What I mean is that two people are trying to write, both of them has to see that system is up. Typically, they should not see that unnecessary failures. Rejects are fine as long as it is agreed upon. So we can say that whenever the DB or any of the write flow, it is reaching the 70% threshold, we can just throw away the additional request, because anyway we have that leeway. And the next thing would be, we are already spreading out the load. We can spread out the load, like if we are getting any spike, we will also rate limit, and maybe parts of the system we will bulkhead. So that way we can increase the availability of the write flow. I think more interesting would be availability of the read flow. That is what was getting clarified here.
Yeah. So
right, yeah. It's mostly about the read. I mean, let's say the try is there, and then they're able to do type ahead, and everything is going fine. But suddenly at time T1, that node went down. So when we do read, I mean, how on the other node the try gets rebuilt?
No. So try will not get rebuilt in that node, because node is stateless here. So immediately the choice I have taken is the caching is it will be on a distributed key value pair. So because it is a distributed cache, typically a KV as my choice. That node, definitely it will not be a compute node. Now, if we are talking in terms of data node, so there are two things why the system could go down, or that the data node, cache node could go down. One thing is the load. So I think this load would not be an impacting thing here. Another thing is, maybe there was a patch at the server level. So a kernel patch was to be force applied. So what will happen is, then we will have to, the system typically either it will be designed automatically or manually. We can degrade, basically we can shut down the master node, especially in the model of Redis. We can shut down the master, and automatically another node will take up as a leader, and it will start taking the right. So typically in this Redis model, it is consistent data source. So there what will happen is the followers will have exact same copy of the data. So what will happen is, if someone else takes up that thing, it will still be able to serve the traffic. So I don't see that in the read flow a sharded, basically replicated a key value store would suffice here. That is how I see. And just for load reduction, we can have some sort of sharding here. So that should be sufficient for the read flow, so to say. Any concern do you see? Then maybe I can highlight if I'm missing by.
I think we can move on to text discussions on Discord on the weekly system design channel. So
okay. Yeah. I think
I'm also going to write something. I'm also going to write something, some feedback. I'm just going to end with just oral feedback. I could say a lot of things. I mean, you did great. It's really detailed. I think eventually the solution is really close to the one that is wanted. Just precise clearly that you're not storing the try, but a processed try that is only a hash map, a hash table. I think it's important, right? You're not really storing the tries, you're storing the hash map version of the try with all prefixes. I think everyone got, a lot of people got this, but not everyone. So maybe your interviewer wouldn't know. That's just the first one.
Okay.
Because I would have a lot of feedback, but I need to finish quick. The second one is, here you had a lecture mode, and it's different than the mock interview. So we cannot ask you to behave like a mock interview, because it's not. But keep in mind, if you're doing a mock interview, when you're being asked question or clarifications, try and make it so that your answers are like 3 to 5 sentences, so that your interviewer can then react. You see, the interviewer can then react and say something like, okay, and so that it's more of a dialogue, dialogue, right? But here I understand why you wanted to make them longer, right? Because you had a lot to say. Right.
Yeah. So that's a really good thing you caught, actually. I tend to be very motivated to speak a lot, actually, when I know.
You can say something like, hey, when someone asks you, for example, on MapReduce, what is it, file system, is it on disk, etc., you see, well, there are multiple trade-offs. I think file system will do that. This other way of storing would do that, etc., etc. And personally, I would choose that. What do you think? Now,
Sure,
the
sure.
problem is,
Yeah, got it. Yeah, go ahead, please.
And that's it for me. It was really detailed. Let's move on to the discussion on Discord, and
Yes.
we'll let everyone in this conversation add something.
Sure. I think I'm good. So I'll just stop my screening and then we can talk for a few minutes and then go. Yeah. So I see a lot of questions here. So where all of those asked, do I need to capture it or answer it, something like that? Because there's too many actually.
Yeah, we had a conversation on the chat.
So were they already taken up or we will take it up offline? Anyway, let's take it offline. I think I'm fine. Yeah.
Anyone wants to add anything? All right. I'm counting to 3. 1, 2, 3. All right. Well, thank you, everyone. And have a good evening.
Yeah, thanks everyone. So I would like to take more of these sessions next time. Yeah, sure. Thank you.
Yeah, it would be great. Bye.
Bye.